Okay, I'm going to explain Hardy-Weinberg as quickly as I can. Okay, say we have 62 individual bats at Zippo Lake. Short ears is recessive, long ears is dominant. 8 bats have short ears. Questions: what is P and what is Q? So we look at this Hardy-Weinberg equation. P squared plus 2PQ plus Q squared equals 1. And P squared is going to be homozygous dominant individuals, heterozygous 2PQ, homozygous recessive Q squared. So you can find Q squared because that's the percentage of the 62 bats that have short ears, which is 8. So we have 8 divided by 62 is 0.13. That's Q squared. Q is the square root of 0.13, which is 0.36. That means that Q is equal to 0.36, or 36% of the alleles in the population are for short eared, which is what Q represents. P is equal to 1 minus Q, because if an allele isn't short ears, that means it's long eared. So P equals 1 minus 0.36. P equals 0.64, or 64% of the alleles in the population are for long ears. That's the most important things: the frequency of the recessive allele, frequency of the dominant allele. If those stay the same over generations, that means populations at genetic equilibrium. If they change over a few generations, then it's evolving. Something like mutations, natural selection, migration, genetic drift, some of those things is happening. Some other questions could ask you, looking at the Hardy-Weinberg equation: how many bats are homozygous recessive?